Alright, so this is lesson 1.06, the first of 2 lessons that'll be on the 1.08 quiz. And our focus in this lesson is the idea of a pure substance, which can be broken down into elements and compounds. So you want to focus on being able to define and distinguish, to tell these things apart. I accidentally deleted a slide. I'm going to throw a definition on here for you. So a pure substance it is something that cannot be broken down by physical methods. Alright? That is the definition of a pure substance. I know we haven't talked about what physical methods are yet, but essentially physical methods are simple ways of breaking things down or separating things. Some pure substances can be broken down by chemical reactions, which is a chemical method, but other pure substances can't be broken down at all. Alright, so you can kind of just remember that they can't be broken down, or the best detail is remembering that they can't be broken down by physical methods. So there's your definition of pure substance. There are 2 types. We call them elements and compounds. Alright. So elements are anything that is made up of the one single type of atom. So all the atoms in that substance are the exact same kind of atom. Alright? And elements are the pure substance that cannot be broken down by physical or chemical changes. Alright? Because it's totally pure. It is just oxygen, or just iron, or just carbon, or just silver, that sort of thing. So I'm hoping that based on giving you kind of this list of examples, you're thinking of something familiar. Alright, so if you want an all-inclusive list of every possible element, go to your periodic table of elements. Alright, so everything on here is an element. Alright, so any individual box on the periodic table of elements is an example of an element, as long as the substance you have in your hand is made up of just that element. Alright, you gotta have pure carbon, pure oxygen, pure magnesium, pure potassium. Alright? Now, chemistry would be really boring if this was the only pure substance we had. All of these guys in them. Alright, there'll have to be 2 symbols or more from your periodic table, whereas elements will just have 1 symbol. Periodic table slide, alright, everything on here begins with a capital letter. Now there's more than 26 elements, so we had to use some 2-letter abbreviations, and when you use a 2-letter abbreviation, the second letter is lowercase. Alright, so if you're needing to figure out kind of like where one atom begins, or where one atom ends and the next one begins, just focus on those capital letters. Those are going to be your new atoms in your formula. Another type of pure substance is a compound. Alright, and compounds will always have at least 2 different types of atoms that are bonded together. Alright, and that's the key thing, where to break bonds, you must have a chemical reaction. Alright, physical methods are things like filtering or evaporating. Alright, those don't break bonds. Alright, the only thing that breaks bonds are chemical reactions. So, common compounds that you are familiar with are going to be things like water, right? Water, and also compounds, they all have a formula that we can give, because the atoms are going to be bonded in some sort of specific ratio. Alright, so you're probably familiar with water's formula is H2O. The slide moved on me. Alright, or there's also sugar. Right, that also has a pretty, hopefully recognizable formula to use, C6H12O6. All right, got some more examples of their formulas over here, but compounds will always have multiple. All right, so real quick practice item here. Go ahead and give this a shot, pause the video, see if you can correctly identify these as elements or compounds, and then start the video back up and you'll be able to see if you were right. So, looking these things over, in this first one, all right, I see hydrogen and oxygen, which means I see two different atoms. All right, so the presence of two different atoms means that this is a compound. All right. Then in this next one, I see two oxygens, both the same type of atom. All right, so if everything in there is the same atom, then you've got an element. Then my next one, I see hydrogen and I see carbon. All right, so there's it's at least two different types of atoms, so that's going to make this a compound. And the last one, both of these are hydrogens, so they're both the same atom, same type of atom, so that is another element. All right, so if you see two different symbols for two different types of elements, or two different types of atoms, that makes it a compound. If you see only one symbol, so that means everything is the same kind of atom, then that's an element. Another thing that is good to talk about now in conjunction with this is kind of how to read a formula. All right, so throughout the rest of the class, we're going to be using these, and we're going to have to be able to, count how many hydrogens there are, how many oxygens there are, and whatnot. So for now, I want to ignore this 3. So we're going to pretend that's not there, and it's just H2SO4. So these little numbers, these subscripts, the 2 and the 4, they apply to just the element right in front of them. All right? So that means that this compound has 2 hydrogen, 1 oxygen, I apologize, 1 sulfur. All right, so if there is no number at all, think of that as being 1. It's just chemists get a little lazy and they don't want to write the ones. Or they're trying to be efficient, because if we take the time to bother and write the S, that's because there's at least 1 there. If there's more than 1, then we got to tell you how many there are. But if there's just 1, then all we can do is write the symbol. All right, so you don't need, and I'm afraid of what I'm deleting here. Okay, you don't need to write a 1 when there's just a single one. So there is 1 S, and 4 oxygens. All right, so that's just looking at that component. Now, if I don't think I can get rid of that without deleting everything. If I now bring in the 3, that's okay, I'm going to delete it all. Oh, there we go. If I bring in the 3 into this equation, all right, this 3, it's a big 3, we call it a superscript. We also, or more often, and especially when we get into balancing, you're going to see it being called a coefficient. All right, so it's big, it's out front, and this kind of, treat it as if your whole compound was in some parentheses. All right, and in math class, when you've got something outside parentheses, you end up multiplying it in to everything. All right, so it's going to be 3 times however many hydrogens there are. So 3 times 2, which would be 6 hydrogens. It's going to be 3 times 1 sulfur. So it'll be 3 sulfurs. Or it'll be 3 times 4 oxygens, which would be 12 oxygens. All right? So, Hopefully this is making some intuitive sense. It's just kind of simple counting sort of stuff, not crazy hard math. Let's practice it some. So we've got these guys here, and the questions, this one's not going to be a good pausing one because you don't have the questions in front of you. But first things first, that first chemical formula, capital C, capital O, how many different kinds of atoms are in there? I hope you are thinking 2. All right? One way, and I should have mentioned this earlier, but each capital letter will be a new atom. All right, because if we go back, all right, so C, capital O is 2. The next one, C, capital C, lowercase o, that's cobalt. That's just one kind of atom. All right. Oh, my subscripts went away. That's no bueno. So this is actually supposed to be C, H2O. And this should look like C6H12O6. And this should be NaNO3. And there's a 2 in front of this one and a 5 in front of that one. Okay, so let's just do some kind of practice counting here. In that 5H2O, how many hydrogens are there? So give it a second. See if you can decide which letter or choice matches up there. All right. So in 5H2O, there's going to be 5 times 2, or 10 hydrogens. All right, 10 hydrogens. Next one, how about how many hydrogens in the next one, the C6H12O6? All right, this one's a little bit easier. There's no coefficient out front, so there's just those 12 hydrogens. The little subscript number following the symbol is what tells you how many there are. And let's try another one. How many nitrogens in the 2 at NaNO3? So just so you know, the symbol for nitrogen is N. Na means sodium. So and then for this one, you gotta remember this 2 is going to get multiplied by the 1. So there are 2 nitrogens. And one more practice one, how many oxygens are in that 2 NaNO3? Again, that you're going to do 2 times 3 equals 6 oxygens. All right, so hopefully you have a good handle on reading chemical formulas and being able to tell apart elements from compounds.